Okay, on this lesson we're going to be looking at polynomial basics. So you've probably heard the word polynomial before in Algebra 1. So let's review that. So it says polynomials can be classified by their number of terms, which are the parts of an expression separated by an addition or a subtraction sign. So if we look at this first example here, there is no addition or subtraction sign. So this is all one term. So if it's just one term, that's called a monomial. And then the sum of two monomials, which there's two terms here because there's a plus sign in between them, is a binomial. And then the sum of three monomials, so notice there's three different terms here, that's a trinomial. And then a monomial or sum of monomials, which is just a general term, is just the polynomial. So that can be four or more or just one. So anytime I refer to a polynomial, it's just talking about the sum of monomials. Okay, so polynomials can be classified by their degree. For single variable expressions, look for the variable with the highest exponent. So that's what a degree is, the highest exponent if there's a variable. The value of this exponent is the degree of the polynomial. So this right here, it says a polynomial degree 1. Notice we have a variable and that exponent is a 1. This is called linear. We already discussed this. When you have a polynomial of degree 2, notice your highest exponent here is a 2. That is quadratic. The polynomial of a degree 3, notice your highest exponent is 3. That is a cubic. And a polynomial of degree 4, notice our highest exponent here is 4. This is called quartic. Okay, so it tells us polynomials do not contain variables that have negative exponents, variables that are in the denominator, which is the bottom of a fraction, variables that have non-integer exponents, which means fractions. So notice that exponent is a fraction, or variables that are under a radical, which is a square root, a cube root, a fourth root, and so on. So those examples there would not be a polynomial. So example 1, we're going to determine if the expression is a polynomial. If so, we're going to complete the chart by stating the degree, the number of terms, and we're classifying it by its degree and number of terms. If the expression is not a polynomial, we're going to explain why. Okay, so first thing, we're going to look at our degree. Remember, degree is your highest exponent if you have a variable. So that would be a 4, because notice we do have variables. We don't have any negative exponents. We don't have any fractions as exponents. We don't have a variable in the denominator or radical. The number of terms that we have, notice there are 3 terms. So we are going to classify it. So based on the degree, there's 4 terms, or 4 degree is the 4, which is quartic, and then there's 3 terms, which is a trinomial. So this is a quartic trinomial. Okay, so the next one, I notice there's a fraction. There is a variable in the denominator. This is not a polynomial. The reason for that, there is a variable in denominator. Okay, so looking at the next one, notice we do have a variable. The highest exponent is a 1. Remember, that's called linear. And then notice we have 2 terms. So this would be a linear binomial. Looking at the next one, notice the highest exponent is 3, so that's your degree. There's 1, 2, 3, 4 terms. So since my degree is 3, that is cubic. Since I have 4 terms, remember the 4 terms, that's a polynomial. We'll just say polynomial. All right, part E, notice there is a square root, which means it's not a polynomial. The reason is because there's a variable under a radical, which is a square root, cube root, it could be anything, but this one's a square root. Okay, so notice the next one. We have a variable. The highest exponent is 2, so that's our degree. Notice there's no addition sign or subtraction sign, so this is only one term. So based on our degree, if it's 2, it's quadratic. And then it's one term, which is called a monomial. So there we were looking at our degree, which is the highest exponent, number of terms, and then we were classifying it based on our degree and number of terms. Okay, let's take a look at the back. So here we're going to be adding, subtracting, and multiplying polynomials together. So really you've done this in Algebra 1, but we're going to review it. So we're going to add or subtract polynomials by combining your like terms. To combine your like terms, you're adding or subtracting only the coefficients, which are the numbers in front of the variable. The variables and their exponents do not change. Okay. So notice here, we were combining like terms that have the same variable, same exponent. That's why that's in parentheses, because you can combine them. And then we could also combine the 7x minus 10x, and then we have that 1 at the end. Okay, so we've already talked about how to add and subtract polynomials. So now let's look at multiplying them. Multiply two polynomials by multiplying each term in the first polynomial by each term in the second. Then we're going to simplify by combining like terms. Okay, so again, we're going to take this first one, we'll multiply it by all 3 of those other terms. And then I'll take the 3 and I'll distribute it to all 3 of those. So that's where this part came in and this part. So once I multiply them, then you're just combining your like terms like we did on that previous example. Okay, so let's look at part A. So first off, notice that we are subtracting in between the parentheses. So really this is a -1 here. So what I need to do is I need to distribute that -1 all the way through those parentheses. So I'm rewriting my first term. When I distribute, I get minus 2xy minus 5x squared y. And then that becomes plus, because a negative times a negative is a positive, 6xy squared. Okay, so we're combining like terms. So I have just an xy. So remember, it has to have the same variable, same exponent. So I'm looking for another xy. Notice we do have one. We're only combining the coefficients. That would be 3, and then I'll leave it as xy. So I like to mark out as I go through so I know what's left. Next part, notice I have an xy or x squared y. So I'm looking for another x squared y. Pay close attention to the signs in front of each one. We are doing +3 minus 5, which would give us a -2, and then we're leaving our variables and exponents alone. We do not change them. So I've combined those two, and notice all we have left here is positive 6xy squared. So none of those are like terms anymore, so that would be my final answer. So remember, when you're adding and subtracting, they have to look exactly the same as far as your variable and your exponent. Okay, So let's take a look at part B. So we're going to distribute because we have parentheses and then we have a term on the outside. So I'm going to multiply these, multiply the coefficients, that's 10, and then I have an A and a B. So 5A times 2B is 10AB. That's all one term. Then I need to distribute it to this one. So multiply the 5 and 3, we get 15, and then we have a variable A. That's all one term. Distribute, so 5 times a negative 2 is a negative 10. Now we're multiplying the A times the AB. A times A, they have the same variable, so we add the exponents, and that's A squared, and then your B. So A times an A is an A squared, because you add the exponents to get 2. So after we distribute, we're looking to see if we have any like terms. This one has an AB. Notice there's not another AB. This one only has an A. Notice there's not anything else that only has an A. This one has an A squared B. So these are not like terms. This is my final answer. So sometimes you're able to combine, sometimes you're not. So you pay attention to the variable and the exponent. All right, let's take a look at the next example. So notice I have 8k squared minus 7k, and then I have a subtraction sign and a 1/2, and then I have parentheses. So I'm going to have to distribute that all the way through. So negative 1/2, which means half, divided by 2. So negative 1/2 times 6 would be a negative 3. Half of 6 is 3, but it's negative. Distributing, that would give you positive 4k, because a negative divided by, or negative times a negative is a positive. And then negative 1/2 times k to the third power, or k cubed, is a negative 1/2 k cubed. Okay, so we're looking for like terms. So notice my highest exponent here is squared, or cubed. And notice all of them are k. So I like to just put it in from the greatest to the largest, or greatest to the smallest exponent. So I'm going to go ahead and write the negative 1/2 k cubed first, because notice there's not another k cubed, so I can't combine it with anything. Next, I would put the squared, but notice there's not another k squared, so I'm just going to write that next. And then I would come with the k. So combine the k's, negative 7k plus 4k is a negative 3k, and then bring down that minus 3. So again, it doesn't really matter the order that you write it, but I like for, if it's all the same variable, just different exponents, I like for the highest exponent to be first and then just go down from there. Okay, part D. Notice we are multiplying two binomials together, and then we're going to subtract. So we first have to use PEMDAS by multiplying. So if you remember from Algebra 1, when you multiply a binomial times a binomial, you use FOIL. So I multiply the first terms together. 3d times 3d is 9d squared. And then I need to multiply it by 4, so the outside terms. 3d times 4 is 12d. Multiply your insides. Negative 4 times 3d is negative 12d. And then multiply your last terms. Negative 4 times 4 is a negative 16. Then, right here, notice that I have this negative 1. I need to go ahead and distribute it. So that would be minus d. That would be plus 2. I'm going to go ahead and start combining like terms. Notice I have a d squared, but notice there's not any other d squared, so I'm going to rewrite that. I have a 12d, it's positive, and then I have a negative 12d. Those are going to cancel out, but I also have a minus d, so I need to bring that down. So then I have a negative 16 plus 2, which equals a negative 14. So there's my final answer. So you have to use PEMDAS. We had to multiply before we could subtract that d minus 2 there. So anytime I'm multiplying two binomials, I need to use FOIL. Multiply the first terms, outside terms, inside, and last terms. All right, let's take a look at E. So I need to distribute. So I need to multiply these together. So multiply the coefficients. -2 times 3 is a -6. V times, excuse me, V times V cubed would be V to the 4th, because anytime I'm multiplying, I'm adding the exponents. I need to continue on. -2 times a -5 is a +10. V times V squared is V to the 3rd power. And now I'm doing, this is a 1. -2 times a -1 is a +2. V times V is V squared. And then the last one, -2 times 4 is a -8, and then we just carry over that V. So we're looking at our V's. Notice there are not any that have the same exponent, so we cannot combine any of them. So sometimes you're able to combine like terms, sometimes there's not like terms. All right, last one. Notice this one is 2x minus 9 squared. Anytime I'm squaring something, we are multiplying it by itself. So I want you to rewrite this as 2x minus 9 times 2x minus 9. So a lot of students make an error on problems like this. They want to put 4x squared plus 81. That is not correct. Okay, the reason for that is because anytime I have a binomial squared, it should always give me a trinomial. So I have to use FOIL here. So multiply the first terms together, you get 4x squared. Multiply the outside terms together, you get -18x. Multiply your inside terms together, you get -18x. And multiply your last terms together, you get +81. So after you use FOIL, you need to combine your like terms. Notice my like terms are the x's on the middle. So I have a 4x squared. When I combine the -18 and -18, that's -36x. And then bring down your +81. So notice I got a trinomial. So anytime I have a binomial squared, your answer should be a trinomial, which is 3 terms. Okay, so this is adding, subtracting, and multiplying polynomials. We are not doing number 3. So if you have any questions, please let me know.